In this tutorial, we're going to present the use of LiveRecorder's Thread Fuzzing feature. With Thread Fuzzing enabled, LiveRecorder will interfere with the thread scheduling of the process being recorded in order to increase the probability of uncovering concurrency problems. Such bugs may be very rare in normal conditions, but through Thread Fuzzing, they can become statistically more common. This implies that tests which may expose concurrency bugs should be run under LiveRecorder many times as necessary to reach a desired confidence level or until a failure happens. The resulting recording generated by LiveRecorder will then be used for root cause analysis. Remember, all of this is possible without making changes to the code of the debuggee. Now we will exemplify the use of thread fuzzing while recording processes for the LiveRecord tool. In this context, the preferred method of activating thread fuzzing is by adding the thread fuzzing option in the call to LiveRecord. To demonstrate thread fuzzing, we're going to use a simple multi-threaded application where one thread populates an empty char pointer array of size 100 with a string hello world, while the other prints each element from the array. There is no explicit randomness in the program, so it should produce the same output each time it is run. Suppose now that someone claims to have seen this program fail, but there is no concrete evidence to base this claim on. Without additional information, the best we can do is try to reproduce the problem, so we're going to run the application many times. Apparently, there is no issue, so it is possible they were wrong. However, if we are not completely sure, then we can repeat the testing procedure for many more iterations. At this point, we can be completely confident. The program indeed has an issue, but one that is very hard to reproduce, judging by its meager 0.03% failure rate. Now imagine that this was a complex, critical application, and not one made up of 50 lines of code that execute in a fraction of a second. How long would it take to reproduce and then debug an issue with such a low probability of occurrence? Now let's use the LiveRecord tool with thread fuzzing enabled. In this first run, we notice that no error was encountered. In order to make the process more expedient, we can use LiveRecord's option Save On, so that recordings will be saved to disk only in the case of an error. As can be seen, execution was again without problems, and LiveRecord informs us that the recording was not written to disk. In order to benefit from thread fuzzing, we need to run the tester application a relevant number of times. That is, as many times as needed in order to obtain one recording of the failure, or as many times as needed to reach a desired confidence level. In this tutorial, we will exemplify both alternatives. First, let's run LiveRecord in a loop until the first recording is generated. We can check that a recording has indeed been generated. Now let's run it in a loop for 100 iterations. As we can see, the situation has changed. LiveRecord has generated one recording corresponding to one execution that failed. This means that the failure rate for this test run is 1%. This is 2 orders of magnitude better than the 0.03% achieved previously without LiveRecord and thread fuzzing. Thread fuzzing has 4 components. The first is thread starvation. This attempts to encourage race conditions by randomly picking some threads and preventing them from making progress for a short period of time. The second one is random thread slices. This randomizes and often decreases the number of basic blocks before a thread can switch, thus increases the number of thread switches. Third is switching inside basic blocks. By default, LiveRecorder doesn't allow basic blocks to be interrupted. With this option, thread switches can happen anywhere. The fourth and final component is switching at the locking or syncing instructions. By allowing extra thread switches around these instructions, we can make it more likely that another thread, where locking is not done correctly, will be run at this point, exposing a concurrency bug. Thread fuzzing can also be used through the LiveRecorder API. Two steps are required to enable thread fuzzing in an application that already integrates LiveRecorder. First, we need to include the UndoLR thread fuzzing header file in order to use thread fuzzing. Then we have to call the UndoLR thread mode set function and pass it the thread fuzzing components that we want to use, as specified through the UndoLR thread mode T enumeration. In demonstrating this way of using thread fuzzing, we will start from an application that already integrates the LiveRecorder API in order to generate recordings when the recorded program crashes. The first step in this process is to include the UndoLR thread fuzzing header file. Next, we need to go to the main function and add a call to the UndoLR thread mode set function so that we specify which of the 4 thread fuzzing components we want to enable. In terms of the argument that we will pass to this function, if we want to have a similar behavior to that of using LiveRecord's thread fuzzing option, then we will use the UndoLR thread mode thread fuzzing default enumeration value. This includes the starve component, the random component, and the MBB component. Now let's compile this program. After we run it, we can see that the program executed correctly. In addition, no recording has been generated. Now we can simply let the program run in a loop until a recording is generated. In this tutorial, we have presented the thread fuzzing feature of Undo's LiveRecorder. Thread fuzzing enables LiveRecorder to interfere with the scheduling of the debuggee's threads, thus increasing the probability of identifying concurrency issues. There are 4 components implemented in the thread fuzzing feature: starve, for delaying the execution of a thread; random, for doing a thread switch after a random number of basic blocks; MBB, to allow thread switching while executing a basic block; and sync, to allow thread switching around locking and syncing instructions. Thread fuzzing can be used through both the LiveRecord tool and the LiveRecorder API. For more information, visit Undo's documentation page at docs.undo.io.